Do we even need 250 watt CPUs, right? That's the question we're trying to answer today. Already died. Welcome back, GigaBrains. Today we have that video we promised you. We have our friend here, the BD790i, hooked up to a 4070 Ti Super, and we're going to do some testing. We've lined up a couple of tests we want to do. We want to compare it to an i7 12700KF today. So that's an 8-core upper mid-range gaming CPU that can still totally drive a high-end 1440p gaming experience, where you're a little bit more GPU bottlenecked anyways. So what do we have lined up? Well, we're going to start with some Cinebench, some single-core, multi-core Cinebench runs, kind of get a feel for both chips, and then we'll transition to some 3D Mark Steel Nomad. Follow that with some Cyberpunk 2077 and Counter-Strike 2, just to get a feel for what both chips can do. My goal is to try to understand if this Ryzen 9 7940HX is a powerful enough chip to replace my desktop chip. Do we even need 250 watt CPUs, right? That's the question we're trying to answer today and get a feel for how that experience is different. We're gonna run Cinebench 2024. This is the most recent edition. We'll start our multi-core test here. We'll just do a 3-minute custom duration test. We wanna get a feel for what the clock speeds are gonna be at full load for the Ryzen 9 7940HX here. So it's starting here on pass 1, and let's observe for a little bit. Let's take a look at power usage here. CPU package power 100.266 watts. So right about where Minisforum claims this chip is going to run, which is 100 watt TDP. One thing to note is we did end up getting some faster RAM in. So the RAM is running. It is DDR5 5600 megahertz CL46 RAM. The maximum speed for this board is 5200 megahertz, and we are seeing 2600 megahertz memory clock here. So doubling that gives us 5200 megahertz. All right, so as we're getting close to the end here, we're seeing temperatures, a max temperature of 78 Celsius, which is not bad, all things considered, with a single 120 millimeter fan mounted on top of that heatsink. That's pretty good. All right, we have our score here. So taking rank number 1 for our program, 16 cores, 32 threads, AMD Ryzen 9 7940HX coming in at 1793 for a multi-core score. Clocking in higher than the Apple M1 Ultra, although a lot of the CPUs that I'd like to see in this list are not in this list right now, and that's all right. We are going to get this number, though, for the i7 12700KF. Now, let's start our single-core run and see what we see there. What'll be interesting is what is the highest single-core speed that we see. So right now I'm seeing a couple cores here at 5.24 gigahertz, 5,240 megahertz, which is a little bit above the rated max clock speed for this chip, which is nice to see as well. All right, so today I learned that Cinebench 2024, set to single core, takes a long time to run. Now we're at the end though, and we've found that the Ryzen 9 7940HX scored 111 points, which is 1 point below the Apple M1 and 2 points below the M1 Max and M1 Ultra, which I think is a very good score. We observed maximum clock speeds of 5.24 gigahertz, again, a little bit higher than the advertised maximum clock speed for this chip. I do think that this is a 7945HX that maybe didn't quite meet the yield for the 5.4 gigahertz max boost clock, and that could be why we're seeing this 5.24 gigahertz, above the spec for the board, but not quite 5.4 gigahertz, something like that. But great scores across the board here. Next up, we have the 3D Mark Steel Nomad benchmark. So this benchmark runs natively at 1440p. You can set it to other resolutions, but that's the native resolution, and that is the resolution of our monitor. We also are running the Galix 4070 Ti.
Is it my real name?
GeForce RTX 4070 Ti Super EX Gamer White V2. A really, really powerful card. Should be able to run any game in 1440p, any AAA game that's out there right now at max settings with good frame rates. So I think this is a good fit. we'll hit that. We'll run that now. Feels very Star Warsy. So we've got our score here for the Steel Nomad benchmark. We came in at 5,507 with an average frame rate of 55.08 FPS. 3D Mark says that's legendary, which I think is a good sign.
Let's play a game.
Next, we are going to test Cyberpunk 2077, a graphically demanding game that we can run to kind of get a feel for what the CPU-GPU combo is capable of doing. Remember, this is a 1440p monitor, and the default preset with the 4070 Ti in the test bench is actually Ray Tracing Ultra. We're going to run through Night City for about 60 seconds and see what we get. Capturing some frames. Try not to get run over here. And perfect. So, summary. Average FPS of 76, a 1% low of 51. Let's run another test. Okay, for kicks, we are going to run the game's built-in benchmark, which is probably a fairly different workload to running through the city. So I'm interested to kind of see the difference between what kind of performance we see in the benchmark versus what we saw in the city. So much more of a GPU load here. It is a very, very good looking game, to be honest. Okay, so we got an average FPS of 94.42, a minimum FPS of 81.96. Let's move on. Okay, next we're going to jump into some CS2 testing here. We'll go through the settings real quick and then jump into some deathmatch on Dust 2, just to kind of keep it standard across the two computers. So we're going to set to full screen display and going into advanced video settings here. I'm disabling VSync, G-Sync as well. Reflex is on. I've maximized maximum FPS in game to 1,000 and then set the preset to very high. So without further ado, let's do this. Deathmatch, Dust 2. Already died. Hopefully that started a frame view because it's the same button as quit the game, apparently. Come on. Oh, all right. One tap with the deagle. Feels good. Got him. 2-0, let's go.
She's doing that selective memory thing.
Oh, all right. And there's our 1 minute. Stop. Okay, average FPS, 283, 1% low of 128. Great frames there, to be honest.
Swish.
Are you flexing right now?
No.
Okay, so we've got our new machine hooked up here. This is my daughter's computer that I just upgraded. So you'll notice the pink cooler, and this graphics card is actually going in her build with some pink ARGB fans. So that'll be fun for her. I just upgraded the CPU and the RAM. So the CPU we're running right now is the i7-12700KF. The F stands for no integrated graphics, but it is identical otherwise to the i7-12700K. So I have here Intel's ARC database just to get a feel for what this chip is. 12 total cores, so it has 8 performance cores. These are Intel's big cores with hyper-threading. 4 what are called efficient cores or efficiency cores for total threads of 20. The max turbo frequency is 5 gigahertz. So this was launched in Q4 of 2021. That was a while ago now, 3 years ago. However, in my opinion, this remains a very relevant chip given that the 13th generation and the 14th generation have had some big issues with degradation, and unfortunately, Intel's most recent Arrow Lake architecture is not as fast as many had hoped. Often coming in slower than the 14th gen, kind of bringing 12th generation back into that relevancy for Intel chips. We have CPU-Z open. We are currently running 64 gigabytes of DDR4 in this case. This is a DDR4 board. 12th, 13th, and 14th generation Intel chips support DDR4 and DDR5. So this is a DDR4 system. Theoretically not the fastest configuration that you can set this up, but it is still fast RAM, 3600 megahertz. We're going to start with Cinebench. We have our custom test duration for multi-core of 3 minutes. And let's jump in. Nothing else is open. We've got HW info and we can take a look at what happens. There we go. Perfect. So we have a maximum P-core frequency of 4,688.5 megahertz. So 4.69 megahertz for the P-cores and 3591. Pretty close to 3,600 megahertz for the E-cores. Looking at some of the other metrics, core temperatures reaching a max of 88 Celsius. So a little toasty there. This is not a super high-end cooler. 5 heat pipe air cooler from Vetru. But the package is reaching all the way up to 90 C high right now. The reason for that is it is running at 192 watts right now, 195 even. Almost 100 watts higher than the Ryzen 9 7940HX in our other board. So double the power. But it is important to note that in this workload, we are potentially seeing a little bit lower score than you'd otherwise achieve with a higher end cooler. The fan isn't as loud as I expected. It looks like it has a max RPM of 2000. It's possible I could strap on a Noctua fan there and get better performance. But there we go. Our first run, we got 1,223 points. All right, so we have strapped the legendary Noctua NF812X25 to the Vetru cooler to see if we can avoid throttling. And here we go. I am seeing thermal throttling happening on P-Core 7, but the minimum speed is not going down. So it is very barely triggering that warning, I think. I think we can call this result mostly accurate for a stock out-of-the-box 12700 KF. That run was actually 1182. Multi-core score of 1182 using the Noctua fan. I do feel more confident having checked the minimum speeds as it ramped up in temperature and watching those speeds stay the same throughout. I'm feeling pretty good about that result. So let's jump into the single core test. So we just finished our Cinebench 2024 single core run. Some things to note here. The top speed that we were seeing, I'm now seeing a little bit higher speed since then, but the top speed I saw during the run was actually 4.889 megahertz. So right about 4.9 megahertz, which is that max performance core boost. I am seeing 5 gigahertz here since this test ended, right? Now that there's no workload, it's extremely lightly threaded. That's when you'll see some of those higher speeds. But during this workload, the highest single core speed was about 4.9 gigahertz. The final score was 111. I believe that is pretty close, actually. So we are about to run Steel Nomad on the i7 12700KF system. So let's jump in here. We are using the same graphics card. We are using the same RAM capacity, but the RAM speeds are different because the Ryzen 7 mobile on desktop platform uses laptop RAM, whereas this is a full desktop platform with the 12700KF. And again, this is DDR4 3600 megahertz. Okay, finishing our run here. Moment of truth, 5547. If memory serves, that is extremely close to the performance for the 7940HX. And there are a number of reasons that could be the case, right? This may be a very GPU bottlenecked test, meaning as long as the chip is fast enough, the CPU is fast enough, you'll get the graphics card bottlenecked score. Let's move on to some of the gaming tests where we have some different types of workloads, some that are more CPU limited, where we might start to see some bigger differences between these two chips. So we are running our Cyberpunk City run-through test for the i7 12700KF system. We are running at Ray Tracing Ultra. That enables DLSS super resolution by default at auto level, which I assume is not very high in this case, given we're running a 4070 Ti Super. It does help with the CPU load, so we'll see less GPU utilization, which is kind of what we want to more directly compare the CPUs. Let's jump in and start our test pass and run through. And then we'll end our benchmark pass. Perfect. So here's our summary. Average FPS of 72, 1% low of 37. We did see higher 1% lows with the 7940HX, so that'll be a pretty interesting thing to compare across the two chips. Let's run the benchmark real fast. The benchmark is more GPU heavy than our city run through, where there's a lot of NPCs, right? To kind of run those instances is taxing on the CPU. So here we'll see higher GPU utilization. We'll probably see a more similar score as well, given we're using the same card. Okay, nearing the end here. And thus we see our average FPS here of 93.56 and a minimum FPS of 81.36. But these numbers are pretty similar, and that's to be expected as we are running the same GPU, and this is much more GPU bottlenecked than the city run through. Let's swap over to CS2, get some deathmatch going, and see how we perform there.
Then he gets shot.
Shoot. So here we've got CS2 on our 12700KF system, swapping over to full screen, changing our maximum FPS to 1000 to make sure there's no in-game setting that's preventing us from going higher, and then switching the preset to very high. Here we go. We found our Dust 2 deathmatch, and now we're getting started. No, I do not wish to exit the game. F10 is apparently how you exit CSGO hockey. Shoot. No! Okay, benchmark summary. Average FPS of 280, 1% low of 116. Average latency of 9 milliseconds. So I do wish to exit the game now this time.
In conclusion,
we've got some results written down here. I'm going to go through some of them. Very interesting, actually. So when it comes to single core Cinebench results, our 7940HX board here, our mobile on desktop platform, scored a 111. The 12700KF, the desktop platform, also scored a 111. So very similar on productivity, single core benchmarking speed. That doesn't tell us a whole lot. So as we go down the list, we start to get a little bit more nuance. With the multi-core, this is where we saw one of the biggest differences. So our Cinebench 2024 multi-core score for the mobile on desktop platform, remember, this is a 16-core mobile chip, was 1,793. Our 12700KF, which is a desktop part, with 8 performance cores and 4 efficiency cores, so a total of 12 cores, but because of the configuration, it has 20 threads in total, as opposed to the 32 threads the 7940HX has. The multi-core score there was 1183, substantially lower, 600 points lower. And here's where I got really impressed with the 7940HX. The max power usage reported by Hardware Info for the 7940HX was 100 watts. And remember that we saw spikes all the way up to 205 watts for the 12700KF. That's crazy. 600 more points at half the power. Honestly, I'm very impressed by that result. It got me pretty excited about the 7940HX. But as we moved on to some more, graphical and gaming benchmarks, we ran our Steel Nomad test. We got very similar scores across the two, 5507 for the mobile on desktop platform and 5547 for the 12700 desktop platform. Those scores are pretty similar. I would imagine that's a pretty GPU bottlenecked test. And so our limiting factor ends up being our 4070 Ti Super in that test. So not a lot of information there that I found very useful for comparing these two CPUs in a more apples-to-apples fashion. So moving on to Cyberpunk, though, there were some very interesting results. In our Night City run-through with the 7940HX, we got an average frame rate of 76 and a 1% max of 51. Conversely, with the 12700KF, we got an average frame rate of 72, slightly below, 4 FPS below, but a 1% max of 37. So significantly more frame drops is what that means. Less of a smooth experience. So again, I was pretty impressed with the 7940HX. As I was monitoring some of our GPU utilization numbers, I did notice the 12700KF was that system was resulting in a little bit lower GPU utilization, just a little bit, right? Suggesting that the 12700KF was actually bottlenecking the 4070 Ti Super a little more than the 7940HX. So very interesting result there. When we run the Cyberpunk benchmark, which again shifts us back to more GPU limited, where the CPU doesn't have as much of a load placed on it, we saw very similar results. 94 for the mobile on desktop, 93 for the desktop platform. And then finally, in our CS2 deathmatch test, so both computers running a deathmatch in CS2, same map for over a minute, to spawn in different areas of the map with different textures and different players. We saw a max FPS on the mobile on desktop platform of 283 with a 1% low of 128. And then on the desktop side, we saw a max of 280, very similar. Not a max, sorry, these are all averages. I guess I'm misspeaking there. But these are average frame rates. The max frame rate is, much higher. But on average, we saw 280 with a 1% low of 113. I guess I've also been misspeaking about the 1% max. These are 1% lows. On the 1% lows, 128 here on the mobile platform and 113 on the desktop platform. Again, outperforming a little bit on the mobile side. I would call this more of an initial foray or an initial investigation. There's a lot more testing that can be done here. And we hope to do a lot more of that on the channel. But with just this light benchmarking session, I am really impressed with the performance of the 7940HX. Remember that it is using mobile RAM, right? So these SODIMMs, they have high speed, right? 56 or 5200 megatransfers per second here, but the timings are pretty loose. And so with this higher end DDR4 RAM here, you might expect that the loose timings on our Ryzen system might hurt it a little bit more. Surprisingly to me, despite using half of the power, our mobile on desktop system outperformed, not substantially, I'd say, but also it was measurable in situations where the CPU was taxed with a difficult workload, especially in Cinebench and again in our city walkthrough in Cyberpunk. In conclusion, this video is making me really excited actually to build my daily driver out of this mobile on desktop system. I do have a laptop with a 14900HX. Could be interesting to do some comparisons there, but this CPU seems really powerful, especially for how much power it uses. So well done by Minisforum on this product, and well done by AMD on the 7940HX, providing awesome performance in a really power efficient envelope. So that'll do it for today's video. Hopefully you stop by next time as we unbox another Minisforum product actually. Should be fun.